I'll say that one more time because this is really important. All the derivatives of the power series, the 0th derivative is just the original function itself. The first derivative is the derivative. The second derivative is the derivative of the derivative, the third derivative, and so on. Every single one of those is recorded in the coefficients of the power series, according to this formula right here. The nth derivative of the function, no matter what n is, maybe your n is 0, maybe your n is 101. That derivative of the function, evaluated at a, is exactly equal to n factorial times the original coefficient that would have been multiplied by x minus a to the power n. So I can actually divide that. Factorial numbers are always positive, so I can always divide by those. And this tells me that the derivatives of this function show up as the coefficients of the power series. Now we need to be a little bit careful. As usual, 0 factorial is 1, and the 0th derivative of a function is itself. But the very important thing here is that the coefficients of a power series are not just random numbers. The coefficients of a power series tell us exactly what the derivatives, plural, the derivatives of that function will be at exactly x equals a. So if you give me a power series centered at 0, say, and you're like, what is the 53rd derivative of this power series at x equals 0? I don't even need to do any derivatives at all. I just look at that 53rd coordinate, and the value of that 53rd coordinate will be exactly the value of the 53rd derivative of the function divided by 53 factorial. All I got to do is multiply back that 53 factorial, and I will be in business. So a power series records every single one of its derivatives as the coefficient. The function's going to be infinitely differentiable. We can take as many derivatives as we like. So my power series here has as many terms as I'd like. There's infinitely many powers of x that I'm adding up. Now, we can also think about this the other way. If I write out that my power series is in fact converging to some function that I've called f of x, then what exactly are my coefficients here? Well, according to the theorem, they have to be this formula. So over here on the left is the function that I want. Over here on the right is the power series. Each x minus a to the power n must be multiplied by the nth derivative of the function, evaluated at a, so I get a real number there. I get the output of my derivative function, then divided by n factorial. So this will work as long as I know that my function is equal to a power series. If a power series converges to some functions, that puts restrictions on what each one of those coefficients is allowed to be. Each one of those coefficients is carrying information about larger and larger derivatives of the function, or maybe I should say further and further derivatives. Once you take one derivative, as long as the function you've got is well behaved, you can take another one.